All right, how's it going, guys? Um, Per some requests of students, I've decided to make a video just to go over all of the proofs that are on your quiz review packet. My hope is that by listening to me and hearing the way we should be thinking about these proofs, you'll be able to gain some more familiarity with it. But I will be honest, with proofs, it takes hard thinking and practice. And that's nothing is going to, there's no quick and easy fix. That's all it's going to take. So here we go. We'll start with part C, number 1. Okay. We are given that NOMW. We are given that O is the midpoint. And we're also given that segment OM, the measure, equals the measure of OW. So, we know that OW and OM are going to be the same. And we also know that O is the midpoint, therefore those are going to be congruent. So, this is a pretty straightforward one. We always want to start with a given. So, we have our statements and our justifications. O is the midpoint. Okay, that's given. Now, a lot of it, you will not be successful with proofs unless you have a firm understanding of the different theorems and definitions that we have encountered. And that's just a matter of fact. So if you're not creating flashcards for these definitions and theorems, then in the long run, you're going to be shooting yourself in the foot because it's going to be very hard to really remember all this stuff. So we know that O is the midpoint. Well, what do we know about midpoints? Midpoints, by definition, separate a segment into two congruent parts. So we then know that segment NO will be congruent to segment OM. And we know that because we know the definition of midpoint. All right, well, our goal is to show that OM is equal to OW. Well, right now I'm dealing with congruence. So in this case, I might want to switch to equality. Okay? Now, before we kind of get into that, when you're going through proofs, you also always want to be referring back to your diagram and trying to create a path in your head of how you come to some conclusion. So let's do that really quick. We know that O is the midpoint. We know that these two are congruent. All right. Well, we know that these two are congruent. Therefore, they must be equal. And we know that OW and OM are equal based on the given. So, if these two are congruent and these two are equal, then that means that these two must be equal, okay? So we're linking, we're transitioning. We're going to use the transitive property here. So, I have congruence. I need to work with equality. So since they're congruent, the distance between N and O will equal the distance between O and M. And that is the definition of congruent segments. All right? Well, we said we know that these are equal. And since these are equal, so let's introduce that. That's our other given. The distance from O to M equals the distance from O to W. That's another given. So since NO and OM are equal, and since OW and OM are equal, by the transitive property, OM and OM And we're looking to prove, sorry guys, we are looking to prove that OW equals ON. So by the transitive property, OW will equal ON. Again, that's because they both equal the same thing. They both equal the same thing, therefore they are equal by the transitive property of equality. Okay. So O is the midpoint. We know by definition of midpoint that it creates two congruent segments. So we know that these two parts are congruent. Since these two parts are congruent, we know their measures are equal. We were given that OW and OM were also equal. Well, now we have the two things that we're looking to prove are equal, are both equal to OM. So they're linked by OM. So since they're linked by OM, we can say that they themselves are equal by the transitive property. All right, next one. Next one, okay. We are given that angle 2 is congruent to angle 3, and we want to show that angle 1 and angle 3 are supplementary. We're given what we need to prove. And our diagram is this little triangle thing. All right? We have 1, we have 2, and we have 3. All right. So we have our statements, and we have our justifications. Now, again, I'm going to keep referring back to how you should be thinking. One way is obviously what we always let's write down our given. Okay, let's get some foundation. Okay, we are given that angle 2 is congruent to angle 3. That's given. All right, now let's look at our diagram. Let's inspect what we need to prove. What's the conclusion we need to reach? And let's try to find some link between what we need to reach and what we have. So right now we have angle 2 and angle 3 are congruent. Okay? We're trying to show that 1 and 3 are supplementary. Well, 1 and 3 are not right next to each other, okay? So what we probably need to do is we need to identify a different supplementary relationship and then somehow weasel 3 into that relationship. Well, let's look. Do we have any supplementary relationships? Well, yeah, absolutely. Angle 1 and angle 2, those are definitely going to be supplementary. Why? Because they are a linear pair. They're right next to each other. And therefore, if we can show that 1 and 2 are supplementary, since we know that 2 and 3 are the same, we could then replace 2 with 3 and show that 1 and 3 are also supplementary. So we're looking at our diagram and trying to get in our head, okay, how do I get to what I want to prove with what I have? So let's start here. If we know, all right, and another helpful hint too. Starting with your givens, that helps, but also focus on what you have to prove. So we need to prove that angle 2 and angle 3 are supplementary. Angle 2 and angle 3 are, 1 and 3. Angle 1 and angle 3 are supplementary. And how do we show the supplementary? Well, we need to show that the measure of angle 1 plus the measure of angle 3 equals 180. So I'm kind of working backwards a little bit to create even more of a link to what I need to do. Now, the reason I did that is because if we go back up here, what are we dealing with? Right now, 2 and 3, we're dealing with congruence. Well, we need to deal with equalities in order to make this equation. So, if we know that those two angles are congruent, let's also say that their measures are equal. And that is the definition of congruent angles. Two angles are congruent if and only if their measures are equal. All right, so we have that down, okay? Well, now we need to work on introducing that supplementary relationship that we do have. Now, we cannot just say, oh, 1 and 2 are supplementary. We can't do that, okay? What we can do is say, hey, those two angles, based on how they look, they are a linear pair. So angle 1 and angle 2 are a linear pair. How do I know that? I know what the definition of linear pair is. Two angles are a linear pair if and only if they have a common side and common vertex, if they're adjacent, and if they're non-common sides. So this side for 1 and this side for 2. If their non-common sides form opposite rays. That's the definition of a linear pair. Well, this satisfies that definition. Therefore, by the definition, they are a linear pair. Now, what do I know about linear pairs? Linear pairs are supplementary. So I know that angle 1 and angle 2 are going to be supplementary. And that is by the linear pair postulate. Okay? So the definition of linear pair allows me to identify a linear pair. The linear pair postulate allows me to then say that those angles are supplementary. Now, because I know they're supplementary, now I know that the measure of those angles, the sum of their measures, will be 180. And that's because I know what the definition of supplementary is. Well, look at this. This connects right down with what we had written before. Now, because I showed previously, oh, I apologize, guys. That should be a 3. Because I showed previously that the measure of 2 and the measure of 3 are equal, I can then replace the measure of 2 with the measure of 3. So I'm using the substitution property of equality to replace those. And lastly, how do I know that 1 and 3 are supplementary? Well, because they add up to 180, and that is the definition of supplementary. So to recap for this one, okay? Not only should you automatically start with your givens, you also want to go to the bottom, put down what you have to prove, and then see if you can think of, well, what is the step I have to show beforehand to get to that? Almost always, you can put one more step above. Okay? The only way I can show they're supplementary is if I show that their measures add up to 180. That provides me some focus when I'm thinking through my proof. Then, what we want to do is also really consider our diagram. Identify what in your diagram do you have to prove? What information do you have? And what's the link between what you have and what you have to prove? All right, next one. Okay. Next one, numero trace. All right, make sure you're checking the interactive calendar because there were some slight errors on this one. Not big ones, but they definitely are going to throw a wrench in you if you weren't paying attention. So, we're given that angle BAC is a right angle. We're also given that angle 2 is congruent to angle 3. That's one of our corrections. And we want to prove that angle 1 and angle 2 are complementary. Okay, let's put up our diagram. We have 1, 2, BAC, and then we have angle 3. All right. So, it's a bit of a longer one. It's 8 steps. So, through it. First step, put down our first given. Okay, so our first given, over here. Okay. We have angle BAC. Is a right angle. That's our given. All right, well, you know what? Before I even do anything else, I know I can do something with that really quick. I'm going to put it in. If I have a right angle, I know its measure is 90 degrees. I know what the definition of a right angle is. Okay. Now, you know what? I think I might go down to the bottom and put in what I need to prove to give me some direction. I need to prove that angle 1 and angle 2 are complementary. And I might also say, you know what? I bet if I'm trying to show that they're complementary, I will need to show that the measure of angle 1, I did this last time. It's angle 1 and 3 are complementary. The measures of angle 1 and angle 3 add up to 90. Okay. I know what I have to prove. I know what the step before that is going to be. That gives me some direction. I need to show the measures of 1 plus the measure of 3 equals 90. Let's go to our diagram. Angle 1 is over here. Angle 3 is over here. The only 90-degree relationship I have is right here. Because I know I'm given that the measure of angle BAC, that BAC is a right angle. Okay? Therefore, if BAC is a right angle, 1 and 2 must be complementary. So that's the only complementary relationship we have in this diagram. Well, how does that link with 3? Well, my other given is that 2 and 3 are congruent. 2 and 3 are the exact same angle. So that means if 1 is complementary to 2, then it must also be complementary to 3 if 2 and 3 are the same thing. So what we have to do is show that 1 and 2 are complementary and then switch out angle 2 for angle 3. So let's go back to what we have over here. We have BAC is a right angle. The measure of BAC is therefore 90. All right. So what we need to do now is we need to somehow introduce this relationship with 1 and angle 2. So let's do that. Well, I know that the measure of angle 1 plus the measure of angle 2 will equal the measure of angle BAC. That's the angle addition postulate. So you know what? I'll be right back. I turn my heat off. It's too warm today for heat. All right. So, by using this angle addition postulate, it creates an equation that includes angle 1 and angle 2. Now, we cannot go right into saying that 1 and 2 add up to 90. We can't do that, okay? The only thing we can say based off this diagram is that the measure of 1 plus the measure of 2 will be equal to this whole measure. But because we know that BAC is right angle and that BAC is 90, since the measure of 1 plus the measure of 2 equals BAC, and BAC equals 90, we can transition across the equality of those expressions and say that the measure of angle 1 plus the measure of angle 2 will also equal 90. That is the transitive property. The transitive property is essentially the law of syllogism. If you notice, it's actually the law of syllogism. Okay? So, we have that statement. We're trying to get 1 and 3 adding up to 90. All right, so we have to somehow now, I want to keep angle 1. We need to show that 2 and 3 are the exact same so that we can switch them. Well, we are given that 2 and 3 are congruent. Let's put that in. Angle 2 is congruent to angle 3. That is given. Well, we're dealing with equality. This is congruence. If we know that angles are congruent, we then know their measures are equal by the definition of congruent angles. Oh, and this brings us now to what we have written before. Because 1 and we get a different color here. Let's do black. Because we know that now 1 and 3 are congruent, I can take that equation that I wrote before that included angle 2, and I can replace angle 2 with angle 3. Now I'm replacing a single term within the equation. I am using the substitution property of equality. And since I've shown that those two measures add up to 90, I can now say that they are complementary by the definition of complementary. Okay. So again, just to recap, introduce your given. If you can think of something right off the bat that you could say right after you're given, go ahead and write it down. It's just providing more information that you can use in your thought process. Once you write your given down, and maybe one other statement, go down to the bottom. Write down what you have to prove. And if you can, write what is most likely going to be what you have to show. So in order to prove 1 and 3 are complementary, we have to show that the measures of 1 and 3 equal 90. Then, go to your diagram. Identify what you have to prove. 1 and 3 are complementary. Then, identify what the links are. Well, I know that 2 and 3 are going to be the same. And since I know that BAC is a right angle, the only complementary relationship we have is angles 1 and 2. So we must have to switch out 2 and 3 somehow. So that's all this mental process that's going on. Okay? All right, let's continue. That was 3. Number 4. Number 4 is a pretty simple one. All right. In number 4, we have given that 1 and 2 are supplementary. Angle 1 and angle 2 are supplementary. And we need to show that angles 3 and 4 are also supplementary. And what we have is we have 2 sets of lines. They are intersected this way. And we have 1 and 3, right? 1 and 3 and 2 and 4. All right. So, let's go through it. First steps first. Let's do our given. Angle 1 and angle 2 are supplementary. That's our given. What's our next step? Well, if we can write something based off the given, let's do it really quick. If these are supplementary, well, I know that the measure of angle 1 plus the measure of angle 2 is 180. Okay? All right, let's show what we have to prove. Let's go down to the bottom. We need to prove that angle 3 and angle 4 are supplementary. Try to go one step above. How are we going to show that? Well, we're probably going to show that the measures of angle 3 plus the measure of angle 4 will equal 180. Because if I can show that, then I can prove that they're supplementary. Okay. We have our starting. We have our end. Let's consider our diagram and see if we can find any links. Well, all right. I'm given that 1 and 2 are supplementary. Okay, that's a relationship that I'm given. All right. Well, you should be very aware of a specific angle relationship here. And we're going to see them a lot. So if you're not aware yet, make sure you find a way to get aware. Okay? We have here vertical angles. Okay? just to recap, any time that we have two intersecting lines, the angles that are directly opposite each other will be vertical angles. It does not matter their position. Okay? They don't need to be directly vertical. Okay? They just need to be directly opposite each other. So here, if you look at our diagram, angles 4 and angle 2, and so 4 and 2, and 3 and 1 are vertical angles. Well, let's think for a second. I need to somehow prove that 3 and 4 are supplementary. The only supplementary relationship I have in my diagram that I'm given is 1 and 2. Now, a lot of times, guys, in order to make some proof, you'll have to set things equal to each other, or switch things, or replace things. If the only relationship I have is that 1 and 3 are supplementary, but I notice that 1 and 2 are supplementary, and if I notice that 4 and 2 are congruent, and 3 and 1 are congruent, if I replace 1 and 2 with 3 and 4, then if 1 and 2 are congruent, if 1 and 2 are supplementary, then 3 and 4 must also be supplementary. Okay? So again, I'm recognizing that in order to show that 4 and 3 are supplementary, I have to replace 1 and 2 with 4 and 3. And we can do that because they're vertical angles, therefore they will be congruent. So, I've introduced my supplementary relationship through my given. That's my definition of supplementary. Let's then introduce our vertical angle relationships. We know that angle 1 is going to be congruent to angle 3, and angle 2 is congruent to angle 4 because they are vertical angles. Vertical angle congruence theorem. Vertical angles are congruent. Now, this theorem has me say they're congruent. I need equality. So since they're congruent, I know their measures are going to be equal by the definition of congruent angles. And since their angles are congruent, I can take the measure of angle 1 in this supplementary equation and replace it with the measure of angle 3. I can take the measure of angle 2 and in this equation replace it replace it with the measure of angle 4. So we're using one more color. I want one more color. Here we go. We are using this equation right here. We're using that supplementary equation. And we're replacing the measure of angle 1 with the measure of angle 3. We're also replacing the measure of angle 2 with the measure of angle 4. And we're getting a new equation. the measure of angle 3 plus the measure of angle 4 equals 180. So that's through substitution, because we replaced individual terms within the equation, and then now we can say that they are supplementary by the definition of supplementary. Okay. A couple more. All right, what we got next? That's 4. Number 5. All right, number 5. We have given at angle ABD and angle CDB are right angles. We're also given the measure of angle 2 equals the measure of angle 4. And we need to prove that the measure of angle 1 equals the measure of angle 3. Okay. One and 2 and 3 and 4. A, B, right? A, B, D, C. All right. All right. So we are given that ABD and CDB are right angles. Okay. So I'm going to mark that diagram real quick to show that. Both of these are right angles. Okay. And I know that angle 2 and angle 3, angle 2 and angle 4 are congruent, or equal, are equal. All right, let's introduce our given, our first one, and let's go down to the bottom as well. So, angle ABD and angle CDB are right angles. That's given. Well, right off the bat, I know if I have right angles, I know their measures are going to equal 90. So the measure of angle ABD is 90, and the measure of angle CDB is 90. And that's the definition of right angles. All right, if I know if I have right angles, I know their measures are going to equal 90. And down to the bottom, I want to prove that the measure of angle 1 equals the measure of angle 3. Now, how might I do that? All right. Well, we could, if we somehow showed that 1 and 3 were congruent, we could show that their measures are equal. But if we look at the information that we have in our givens, okay, and in that second step we wrote, we don't have anything that's dealing with congruence. So while we could put it in there just to help us guide, it might not be the best of decisions. Okay? So we're going to leave it out for now. Now let's go to our diagram. Okay, let's see what we're working with. Okay, we need to show that 1 and 3 are equal. We need to show that this angle here and this angle here are the same. Now, a lot of geometry is recognizing the relationship between parts and wholes. Okay? So, let's look what we have here. What we have is we know some information about some wholes, some whole things. We know that both a measure of ABD and measure of CDB equal 90. All right, well, if they equal 90, then this whole relationship, ABD, this big angle and this big angle are the same. All right, that's helpful. They're both the same. Now let's look at their parts. Because what we're trying to show is we're trying to show that a part in each of them, 1 and 3, a part in each of them are the same. Well, if we're trying to show that these two parts are the same, and we can show that these two parts are the same, that's given, 2 and 4 is given to be equal, well then, if we can somehow set the equation of this one equal to the equation of this one, and then just remove angles 2 and 4, then we would be left with 1 and 3. So, let's go to our proof. Right now, I have ABD and CDB both equaling 90. Well, if they both equal 90, then they must equal each other. That's a transitive property. They both equal the same thing, therefore they equal each other. Now I have the wholes are equal. Now I need to introduce their parts somehow. Well, I know that this whole is made up of angle 1 and angle 2. Okay? And I know that this whole is made up of 3 and 4. And both of those are the angle addition postulate. Okay. Now, since I showed that the whole parts, the whole things are equal, then their parts must be equal. And that's going to be the transitive property, okay? Because this entire expression and this entire expression are both equal to equivalent expressions. ABD and CDB I've shown are the same thing. Therefore, these must be the same thing. So that's transitive. Transitive property of equality. Now, my goal is to just get down to 1 and 3. Well, I have an equation now where 1 and 3 are on opposite sides of it. So I'm thinking, all right, well, how do I get rid of 2 and 4? Well, based on my given, I know that 2 and 4 are the same thing. So let's introduce our new given now. I know the measure of angle 2 equals the measure of angle 4. Given. Now, there are many in the math world that says, you know what? Since we've shown that 2 and 4 are the same thing, we can then subtract 2 and 4. But for our sake, I want you to replace one of them first. So let's replace this angle 4. The measure of angle 1 plus the measure of angle 2 will equal the measure of angle 3. Now, since 2 and 4 are the same, we're going to replace this 4 with the measure of angle 2. That is substitution. Now, since both sides of this equation have the measure of angle 2, I can then subtract that measure and be just left with the measure of angle 1 equals the measure of angle 2. So our final step is the subtraction property of equality. That's that. So really this one was a big focus on the concept of wholes and the parts that make up them. We recognize that because ABD and CDB, ABD, this large angle here, and CDB here were right angles, that those two whole things were going to be equal. We then recognized that the thing that we wanted to prove were parts within those holes. So if the picture, if we can show the holes are equal, and then we can show the parts that make up them are equal, if we can then subtract or remove some of the parts, we might be left with just the parts that we're trying to show are equal. All right, last problem, number 6. Number 6 was left completely open. So, if you're watching this video, I want you to stop, go and try to do number 6 on your own, and then come back and watch the rest of the video. Okay. You're given that AC equals BD. You're given that Okay. Alrighty. Let's get to it. Hey, blue marker. Okay. Alright. Statements on one side, justifications on the other. Alright. Well, first things first, let's put down our given. And I'm going to go ahead and put down what I have to prove. Okay. You know what? there's not really anything super obvious that I could put after either of these. So now I'm going to go ahead and look at my diagram. I'm given that the measure from A to C is equal to the measure from B to D. Okay? And I need to prove somehow that AB at this segment is congruent or equal, to CD, that segment. Okay. So the two segments that we have to prove are equal are parts of larger segments that we already know are equal. I then look at those larger segments and I see, hey, you know what? They overlap at segment BC. Okay? So those two holes that I know are equal and which contain the parts that I'm trying to show are equal, those two holes both share the same part. Okay? Well, let's go here. Let's see, all right. If I can somehow create equations for each of my holes, and since those equations both are going to include BC, we could remove BC from both equations and be left with A, B, and CD. All right. So, our given shows that our two holes are equal. Well, let's introduce statements about the parts of each of those holes. I know that the distance from A to B plus the distance from B to C will equal the distance from A to C. That regards my first hole, okay? And that is the segment addition postulate. I also know that in my second hole, the distance from B to C plus the distance from C to D will equal the distance from B to D. That's also going to be segment addition postulate. Now, because I've already showed that AC and BD are equal, that must mean that their parts are equal. Okay? So AB plus BC, the parts that equal AC, must equal BC plus CD, the parts that equal BD. This is the transitive property. We are transitioning across the equality of expressions. We are not replacing any unique term within one expression, within one equation. So, hey, I have my equation. AB is on one side, CD is the other. They both contain BC, so let's just subtract BC from both sides and be left with AB equals CD. The subtraction property of equality. Okay. And that's it. That is it. So, to go over our steps, our thought process. Now, even though the proofs that I give you for the most part will include some of the parts, okay, we'll eventually get to completely empty proofs, okay? Since they're going to contain some parts, you should still go through this thought process. 1, write down your given. 2, is there something that you could say about that given? Could you create a second step? After you do or don't do that, go down and write down what you need to prove at the bottom. Then, can you go up one step? If you're dealing with things like supplementary, complementary, you can almost always get that next step above. Once you have that all filled out, you're then going to go to your diagram. Identify what you have to prove. We had to prove A, B, and C, D were equal. Identify the things that you're given. We're given that A, C, and B, D are equal. Try to find the link between what you're given and what you have to prove. It will often be a situation of parts and wholes, okay? So A, C, and B, D are my wholes that are made up of parts. My wholes contain the same part. That's something that I could remove because it's going to be the same on each side. Okay? And then it's going to take thinking, it's going to take practice for you guys to be efficient at these. But what it is problem solving at its finest. Okay? It's a puzzle. It is deductive reasoning, and it is something that you will use every single day of your adult life. You might not be creating actual geometric proofs, but the process that's going on in your brain that you are learning in this class is what you will use your entire life. All right, I hope this helped. Make sure you study for your quiz, and I will see you guys tomorrow.